Hi, it's Dr. LaGattuta again, and today we're starting with concepts for equilibrium. If you start out with two reactants, A and B, at the very beginning of the reaction, you're only going to have reactants. You're not going to have anything here because products haven't been made yet, unless the question specifically states amounts of products. You're going to assume there's nothing here. So when you make an equilibrium chart, in the I column of ICE, the initial value, you're going to have values for the two reactants, but you're not going to have values for the two products on the at the start. Over time, as this reaction moves forward, then we're going to start to see the products appear. But it's not going to be in the I column. The C in ICE stands for change. How much of that initial value is going to be lost by the reactants or gained by the products. But right now we're talking about equilibrium. Equilibrium means after a certain point when the reaction has moved forward, you're going to see the rate of the forward reaction is going to equal the rate of the backward reaction. But what's more pertinent at this point is to understand that at equilibrium, once you reach that forward-backward rate being equal, that the concentrations of these compounds will remain the same. So we can, at equilibrium, calculate the concentrations of every single compound that you have when equilibrium is reached. So let's see how to do that. We can calculate the concentrations of all the compounds at equilibrium if we have two things. An equilibrium chart and the value of the equilibrium constant, K. So let's look at an example. If we had this reaction, 2NH3 ammonia gas, and the products that form over time are nitrogen gas and hydrogen gas. At equilibrium, which is that final column in the equilibrium chart, the K, or the equilibrium constant, will be equal to the products, each raised to their coefficient in the equation, over the concentrations of the reactants, raised to their coefficients in the equations. So for this equation, at equilibrium, these are our products. So we would have the concentration of nitrogen and the concentration of the hydrogen raised to the coefficient. The coefficient here is 1. So it's the products over the reactants. And our reactant here is the concentration of the ammonia raised to its coefficient. So that would be the value of the equilibrium constant for this reaction. Naturally, then after that, we would plug in the x's or the values that we had, and then we could use it to solve. Now, if your K turns out to be less than 1, that means the top is smaller than the bottom. So that means we have more product at equilibrium. If the K is greater than 1, that means the top of this fraction is larger. So that means at equilibrium we have more reactants. Now, a very important thing to note, so I'll change the color, is you never include any compounds in the K expression if they're solids or liquids. Notice in our example we have 3 gases, so we're fine. All of those compounds can be included. But if any of these were a solid or a liquid, then they don't belong in the equilibrium constant expression. So we'll come back for our next section, how to construct an equilibrium chart.